We'll continue in sections 12.2. Now we want to talk about addition, subtraction, scalar multiplication with regard vectors. So let's say we have two vectors. How do you add two vectors together? Here we'll give an example first. Vector A is 1, 3, and as indicated in the red arrow right there. Vector B is 2, 1. So according to our vector additions, 2, 1, we go at the end, to the point of that, go 2 unit to the 2, 1, 2, and 1 unit up, that's 2, 1. So we're going to produce a vector here. So our final vector will be this. So that will be, so this is the vector of A plus B. As you can see, this vector is ended up what? 3 and 4. Simply it just 1 plus 2, 1 plus 2, and 3 plus 1, 3 plus 1. So A plus B, we can say it is equals to 3 and 4 geometrically speaking, but algebraically speaking, we can say it's 1 plus 2 and 3 plus 1. So we can say A plus B is, with the two vectors, it just simply add component-wise. A1 plus B1, A2 plus B2. Just add it component-wise, okay? But what is the A minus B then? A minus B then. Oh well, let's take a look. We use the same two vectors. Okay, same two vectors here we have. Let's just go up a little bit. Oops. All right, let's do it down just a little. Okay. All right, so 1, 2, here, we look at this vector right there. All right, and maybe I want to move it to the right just a little so I can see better. Okay, let's take a look at this. All right, all right, so A minus B. So now recall B is 2, 1. B is 2, 1. So now B is negative 2, 1. So I'm going to go the other directions. So I want to go maybe negative 2, negative 2, say 1, 1, 2, and negative 1, down 1. So this is my new vector. Okay, so the new sum will be like this. Okay, we can form a parallelogram. Okay, the new vector, so it will be like this. And that will end up with okay, so it looks like it's just going the other way around, so we just change the sign. So we can say A minus B, in our example, would be 3, sorry, my bad. That will be 1 minus 2, 1 minus 2, and 3 minus 1. So it end up with negative 1, 2. Here, just a negative 1, 2. So we can say, in general, A minus B equal to A1 minus B1, just component-wise, A2 minus B2. I think similarly, this is going to extend to the three-dimensional problem. And also for scalar multiplications, if A equals to A1, let's just A1, A2, how about that? Okay, then for any scalar or constant you will call C, C times A equal to simply C times A1, A2. We can distribute either one of them. Simply just magnify or shrink this vector CA1, CA2. So let's look at example right here. Okay, example. All right. So if A, we just three-dimensional example. A equals to, let's say, 4, 0, 3, and B equals to, sorry, and B equals to -2, 1, and 5. Find the following, right? We're going to do one by one. First, what's the length of A? That's simply equal to -2 squared plus 1 squared plus 5 squared. So that was the square root of 4 plus 1 plus 25. Which is square root of 30. Oh, my bad. A, not my bad. So now this is B. So let's go back to that again. Sorry. A is 403. So 8 is square root of 4 squared plus 0 squared plus 3 squared. So which is 16 plus 9 square root of 25. So the length of A is 5, or magnitude of A is 5. B. What is the length of A plus B? We're not worried about the length, so we don't want to do that. Which is simply, what is A plus B? That's just component-wise. That'll be 4 plus -2, 0 plus 1, and 3 plus 5. So the answer is, you get 2, 1, and 8. C, what is A minus B? A minus B will be 4 minus -2, 0 minus 1, and 3 minus 5. We end up with 6, -1, and -2. Finally, we do a scalar multiplication and combine all the other property. So what is a 2A plus 5B? Well, so that will be 2 times 403 plus 5 times -2, 1, and 5. So that will be 806 plus -10, 5, and 25. So add this together component-wise, that will be -2, 5, and 31. So that is addition, subtraction, scalar multiplications.